So this is problem number 1. A student standing over the ground throws a ball straight up. The ball leaves the student's hand with a speed of 2 meters per second when the hand is 2 meters above the ground. Find the distance traveled upwards. So first, to begin, let's start with a simple diagram. Okay, so this is the student. And he is throwing a ball upwards with a speed of 20 meters per second when the ball is above 2 meters from the ground. So, first let's begin with our kinematic table. So we get velocity initial, average velocity, and velocity final. Then we do our change in velocity, then our acceleration, our time, and our change in distance or displacement. So let's fill in what we already know. We know in objects, when they're being thrown up or thrown down or they're in free fall, they always will have an acceleration of negative 9.8 meters per second squared. Our velocity initial, it tells us, is 20 meters per second. Now, if we think about the problem, we know at the ball's highest point, the velocity will be 0, as it's changing from a upwards velocity to a downwards velocity. So our velocity final will be equal to 0 meters per second. Our average velocity is therefore 10 meters per second, as 20 minus 0 over 2 is equal to 10. So now we have our change of velocity, which is negative 20 meters per second, as we take the velocity initial and our velocity final and we subtract the velocity initial from the velocity final, giving us negative 20. Our time we can calculate by using our velocity, our change of velocity, and our acceleration. So the formula for this is change in velocity is equal to acceleration times change in time. So if we look at this, we have a acceleration of negative 9.8. And if we use our calculator, we have 20 divided by 9.8, giving us a time of around 2.04. seconds. Now, if we look at to get our change in x or our displacement, what we will do is we'll multiply our average velocity and we'll multiply it times our time. So we get 10 times 2.04, giving us a displacement of around 20.4 meters. Now, our problem asks for us to give it in two significant figures as 2.0, so we will leave our answer as change in x equals to 20 meters. And that is our distance traveled upwards.